Welcome to the Explainer. Today, we're literally digging deep. We're talking about the ground beneath our feet, the very foundation of our world, rocks and minerals.
Okay, let's unpack that for a second. The ground we walk on, it's not just dirt and stone. It's a library. I mean, every single rock is like a book holding a piece of our planet's incredible 4 billion-year-old story.
So what kind of stories are we talking about? Well, these are epic tales, right? Stories of insane pressure, volcanic fury, the rise and fall of entire mountain ranges, even the history of life on Earth. But to read these stories, you first have to learn the language, the Earth's language. And that language, it really starts with the absolute basics, the alphabet of geology. And that means getting clear on the difference between two things we mix up all the time. Okay, so this is the crucial point right here. Minerals, they're the basic, pure ingredients. Think of them as the individual letters of the alphabet. And rocks? Well, rocks are the finished recipes. They're the words and sentences you make by combining all those different mineral letters. It's a simple distinction, but it's everything. Right, so that organized, orderly, internal atomic structure. That sounds a little textbooky, but it is everything. This is the key, the secret sauce that lets geology pull off this incredible magic trick, taking the exact same chemical ingredient and creating wildly different stuff with it. Just get a load of this. This is the perfect example. You've got graphite and you've got diamond. Both of them, pure carbon. Nothing else. The only difference is how those carbon atoms are arranged. You lay them out in these flat, slippery sheets, and you get the soft graphite in your pencil. But you take those exact same atoms and lock them into a super strong three-dimensional cubic grid. Boom, you get diamond, the hardest natural substance we know. Same letter, totally different words. So how do geologists figure out what's what when they're out in the field? A lot of the time they use this, the Mohs scale of hardness. It's so beautifully simple, but incredibly powerful. It's all based on one question: what can scratch what? You start with talc, down at number 1, so soft your fingernail can scratch it, and you go all the way up to a perfect 10, diamond. Each mineral gets a rank, and it lets geologists do this super quick process of elimination to figure out what they're holding. Okay, so we've got our letters, the minerals, and we've got our words, the rocks. Now let's dig into the grammar of geology. This is the rock cycle, a process that is constantly, and I mean constantly, rewriting our planet's story. You can really think of this as Earth's ultimate recycling program. It's this incredible, continuous loop with no real beginning and no end. It's just always going, driven by the planet's internal heat and all the forces on the surface. So let's walk through the 3 main chapters in this amazing cycle. First up, you've got igneous rocks. These are literally rocks of fire. They're born when that super hot molten magma from deep inside the Earth cools and solidifies. And if it cools really slowly, deep underground, that gives it time for these big, beautiful crystals to grow, creating rocks just like the granite you see in Yosemite. But nothing lasts forever, right? Over huge spans of time, wind and water just break those igneous rocks down into tiny pieces, what we call sediments. Those little bits get washed away, they settle in lakes and oceans, and then, layer after layer, they get buried and compacted for millions of years. And that's how you get sedimentary rock. This is the stuff that often traps fossils, giving us these incredible snapshots at the past. And for the final act, what if you take any rock, doesn't matter if it's igneous or sedimentary, and you bury it super deep inside the Earth? Well, the incredible heat and pressure down there will literally cook and squeeze it. It doesn't melt completely, but it transforms. Its entire structure gets rearranged, creating a totally new kind of rock, metamorphic rock. Now, this is so important to grasp. This whole cycle, it doesn't happen on a human timescale, not even close. We're talking about immense geological deep time. I mean, the rocks that are under your feet right now, they could have witnessed the formation of continents like Pangaea. They could have been around for the age of dinosaurs and seen the last ice age come and go. It's mind-boggling. So, okay, an ancient language, deep time. Why should any of this matter to us, right here, right now? Well, because it's not just some story about the past.
We take the stuff forged in this ancient cycle, and we use it to build our entire modern world. And the sheer scale of our reliance on these materials, it's just staggering. I want you to think about this number, 27.6 tons. That's how much rock and earth has to be dug up, moved, and processed just to find a single 1-carat gem-quality diamond. That's the weight of about 5 elephants for one tiny stone.
And you don't have to go to a mine to see this in action. Just look at your car. It's basically a curated rock collection on wheels. Seriously, the steel on the engine block, that started out as iron ore, a rock called magnetite. The wiring is all copper. And the glass, the computer chips, that's all silicon. Every single critical piece of that machine started its life in the Earth's crust.
And it's not just the car itself. Even the fuel that powers it, petroleum, black gold, is a geological product. It's basically ancient organic stuff that got trapped in sedimentary rock millions of years ago and then cooked into the oil we use today. Finding it and getting it out is all applied geological science.
It really is just that fundamental. I mean, from the salt on your food, that's the mineral halite, to the very device you're watching this on right now. Our entire civilization is literally, from the ground up, built with materials that were forged by our planet's incredible history. And that brings us to a really crucial final thought. The rocks we're mining and using today, they're going to become the sedimentary layers of tomorrow's world. The way we choose to use, to manage, and to recycle these finite resources, that's the chapter of history we are writing in real time. It's a chapter that one day will be read in stone. So the question is, what story is it going to tell?